Hey guys, we're going to do 5.4 today, properties of logarithms. So this is just a quick overview. You should remember some of this from Algebra 2. A couple properties. First, we're just going to look at when the base of the log is the same as what you're taking the log of. The answer is always going to be 1. Just remember, the logs are always saying what's the exponent. So what's the exponent that makes it stay the same is really what it's saying there. The next part of this, what's the exponent that makes b become a 1? Obviously that's 0. Anything to the 0 power is 1. So every time there's a 1 here, no matter the base, the answer is 0. These next couple we're going to spend a little bit more time with. This first one is looking at multiplication. Multiplication will expand to addition, or we can do that the other way and condense addition to a multiplication problem. Similarly, division would go to subtraction, and then exponents. Whenever you have an exponent in part of a logarithm, this property says you just move that exponent to the front of the log. So that's why it's n times the log base b of p. So the number in front is the same as the exponent, whether it's log or natural log. Number in front, same as the exponent. And then here's just a pretty easy property about when you have exponents and logs, they just cancel each other out. So since it's base b in both of these, they cancel each other out. We're just left with a p. Same thing here, natural log and e, they're the same base e. So they would cancel out. We're just left with p. So there's your overview of all the properties we're going to look at. We're going to use some of them. First, log base 5 of 5. Remember we said that's always a 1. To get the same number, 5 to the first is 5. To get the same number, the exponent is always 1. Logs are exponents. To get an answer of 1, the exponent has to be 0. So here's look at our second property we had. 6 is the same as 2 times 3. And multiplication can be expanded to addition. So you split it up as log of 2 plus log of 3. The third example here, the next example has 15. You could think of 15 as being 45 divided by 3. And then, since it's division, we can expand that to subtraction. 45 minus log of 3. Log 45 minus log of 3. And remember we talked about exponents. Exponents move to the front. So it could be rewritten as 2 log of 5. Or 4 can move to the front. It could be 4 natural log of 5. And then the last one we talked about was when the bases are the same, the base of the log and the base there, 3 cancel out, we're just left with 9. E and natural log cancel out, we're left with 5. This one's got two little steps to it. First, that number in front would go to the exponent. And then e and natural log can cancel out. And that's why it's 5 to the third, and then obviously that is 125. So we're going to simplify these. So to do that, we're just going to look at what the operation is. This one has addition, which can condense to multiplication. So you can rewrite this as log of 40, and then addition goes to multiply by 5 over 2. Then we can do 40 times 5 over 2. 40 divided by 2 would be 20. 20 times 5 is 100. So that can all simplify to be log of 100. But this can go one step further because log of 100, log with no base written, means base 10. So that's saying 10 to what exponent equals 100? The exponent would be a 2. So you can finish that off and you just get 2. Now, with all of these, you can check them on your calculator. This would be a good one to check. We can type in log 40 plus log 5 halves. Log 40 plus log of 5 halves. The answer is 2. Subtraction this time. Subtraction goes to division, so we can go log. Again, these bases have to be the same. They both have to be 9, then you just keep it. So 25 minus log 75, this subtraction would go to division, so we can say 25 over 75. And then that can reduce to 1/3. And that actually will have an answer also, because 9 can become a 3 by doing square root. So it would be a 1/2 exponent to make the 9 become a 3. But since that 3 is in the denominator, it has to be a negative exponent. So 9 to the negative 1/2 would equal 1/3. And again, we can check that. We can type in the original problem, log base 9. So I'll go in the calculator to log base, log AB. It's base 9. And then our numbers were 25 first, and then minus log AB, base 9, and this number was 75. Negative 0.5, which is 1/2, negative 1/2. Natural log E, those cancel out. So we have a couple of ways we can do this. Natural log E, they do cancel out. And then we just be left with the 3 in the front. Same thing here, natural log E, that exponent will be a 1. They do cancel out, so that would be minus 1. 3 minus 1 would just be 2. And again, you could type that in. Natural log e to the 3rd. If you just want to do that part first, you'll see that the answer is 3. And then natural log of e is 1. 3 minus 1, it's going to work out. Almost the same property, it's just a little bit backwards. E and natural log cancel out, so this is 3. E and natural log cancel out, that's 2. E natural log cancel out, so that's e. 3 plus 2 minus e. The best we can simplify would be 5 minus e. Can't really do anything else with that. To write as a single log, sometimes that another word for that is condense them into a single log. So the first thing we're going to do is we're going to take coefficients, the numbers in front, and make them be exponents. And then we will take the addition and condense that to multiplication. Now, for that to happen, those bases have to be the same. They are. So that's log 5, base 5. We have x cubed first, and then plus, it's going to go to multiplication, y squared. And that's condensed. When we only write log one time, that's condensed all the way. Same idea, we're going to move coefficients to exponents first. So that 2 becomes an exponent. So we can think of this as natural log of 5. 3 squared would be 9. And then they're all the same log, so we can condense them into 1. Minus means the 9 is going to the denominator. And then 18 with plus, which means it's multiplication up here in the numerator. We can simplify that. 18 divided by 9, that's what I would do first. That would just go to 2. 5 times 2 is 10. And we could type that whole thing in, natural log 5 minus 2 natural log 3 plus natural log 18 and that's some strange decimal, but we can verify that we were right because we'll type in natural log 10 and we get the same decimal. So we were right. Same idea here. We can take the 5/3. We can make that be the exponent, or 3/5 rather. So we have a fraction for an exponent. Remember, that means that the 5 would be the index on our radical, and that would be x cubed. And then same thing here, this would be a y, that's a third root, cube root, y squared. So we've got two logs we are combining, we're condensing, it's addition. Addition is going to condense with multiplication. So that's log base A of, remember we rewrote this here with our 5th root of x cubed. And then cube root of y squared. If we wanted to think back to, I think it was in chapter B, very, very beginning of our school year, we did talk about how we can rewrite these with the same index. You really just go back to when they were fractions. And you just want those two fractions to have the same denominator, so we can make that be like a 15th root if we wanted to. I've already started, might as well finish it. So that would be 9/15, and y, that would be, we have to multiply by 5, so that would be 10/15. And now they have the same denominator, so they have the same index. We can put them together inside of a 15th root. And that would be an x to the 9th, and then a y to the 10th. That's the best way to leave your answer. If you stopped here, that'd be okay. The rest of that was just review. That's why we learned that earlier this year. But all right, same sort of idea. Also going to take us back, use some old skills of ours. Minus, that's going to go to a division problem when we condense these. So this is log base B. So we have x squared minus 1 over x plus 1. And we are very familiar, x squared minus 1 factors. We've done that many, many times. X plus 1, x minus 1 over x plus 1. So the x plus 1 in the denominator cancels out with the numerator, and we are left with just log base B x minus 1. You do want to keep your parentheses there, so it doesn't look like you're just saying log of x and then minus the regular number 1. All right, so now we will expand, doing the reverse of what we just did. We're looking for multiplication and division, or multiplication and subtraction, so we can expand to addition. I think I said that wrong. Addition, subtraction, expand to multiplication and division. So we've got multiplication going on here. Log base 7 of A is our first part, and that is multiplication, so we can write that as addition. and you have to rewrite log, and we'll keep our parentheses, c plus d squared. And then nothing else we can do with this log base 7 of a, but this has an exponent on the second piece here. We can move that exponent to the front. C plus D, and that's all we can do because this is C plus D in parentheses. That cannot be changed. It's only when it's log plus log that we would do anything with an addition sign, if it was log plus log like we have here at the front. So now we have some multiplication and division. So even though this z and w are being multiplied, since they're both in the denominator, we're going to think about them both as being division, as being divided by those things. So as we expand this, we have log base 5 x squared first, and then the multiplication for the top goes to addition of y to the 3, and then this square root means 3/2, so let's go ahead and just write that as an exponent. And now the z and the w are both in the denominator, so it's going to be minus z to the 5th, and minus, because w is also in the denominator, so now we'll do our next and last step for this one, is move the exponents to the front. So the 2 moves to the front, the 3/2 moves to the front, the 5 moves to the front, and the 6 moves to the front. Three-halves, log base 5, minus 5, log base 5 of z, minus 6, log base 5 of w. That's it. That is fully expanded. The other thing you can think about with these, remember this 6 now is negative 6, so it would be like a negative 6 exponent, which is, you know that negative exponents go to the denominator, and that should kind of connect your old exponent knowledge with current log things that we're talking about. All right, here's one more. So we do have multiplication here inside the log, or inside the square root. So inside of a square root, you can think of that as being square root times square root. So we're going to split it up that way. And then since it's times or multiplication, we will expand to addition. Square root x minus 1. And then y to the 4th is in the denominator, so that's going to be minus natural log y to the 4th. The square root is an exponent, so you can think of it as 1/2 power, which means we can now move it to the front. 1/2 natural log, and then we'll just keep parentheses around it like we started with. And the 4 is also an exponent. We move that to the front. And that's it. So a couple of things. Some of these we talked about already. Like the second one here we talked about already, when there's addition inside, you just leave it alone. You stop right there. You do not split it up into log plus log. An exponent on the argument of the log, the x right here, x squared, that is not the same as parentheses there. You can just put some numbers there and you'll see you get different answers. If you put in a 2 for x or something like that, you'll get different answers. When it's written this way, that 2 can move to the front. That's not the way this works here. You have to actually get the answer and then square the entire answer. And then same thing, or similar to what we looked at on number 2 right here, when you have log on top and bottom, that is not when you expand, or when you expand it to be subtraction. You just leave it as log over log. This is actually the change of base formula that we talked about yesterday. So this problem could actually be rewritten as log. Remember, the denominator would be your base. That would be simplified, not into a subtraction problem like that. So practice these. They're a little bit tricky at first, but the further you go with math, the more important logs will be. If you go into calculus, you're going to use logs a lot just to help simplify some problems that are pretty complicated. So leave your comments, leave your questions in our discussion, and I'll see you guys later. Talk to you later.